Hi, everybody. Sorry for the long setup. My name is Adar Weiss. I'm from Pure5, co-founder and CEO. I've been working on distributed system for the last 13 years, and it's really exciting for me to be here. I started at the Israeli Defense Force, then worked for a few startups and for the government in cybersecurity projects. And it's really exciting to apply this knowledge and experience on streaming. And we'll get to that in a second. Pure5 is a serverless CDN. So we definitely took a different approach in CDNs. We're not deploying more and more servers. We built a peer-to-peer mesh network that scales with the demand, and this is how we deliver the content. Today we're going to talk about adding peer-to-peer to a multi-CDN environment and why it is awesome. So let's start by talking about multi-CDN, and we talked about it earlier in the keynotes, but I think it's important to mention Yahoo as a very important example of why multi-CDN is essential and why we're going to see more and more multi-CDN in the future. So why do I think Yahoo used multi-CDN? So they had a huge event just last October. It was the NFL game in London. And basically, they worked with 8 different CDNs, and I think that's amazing. And the main reason is that they had to stack capacity. So they pretty much asked everybody, how much capacity you have, we need it, we want more and more and more, because they broadcasted a huge football game. And no single CDN can cope with that demand and the amount of capacity that is needed for live sports for such a huge event. A company like Yahoo and other broadcasters needs the infrastructure to be fault tolerant. So what does that mean? It means that you can't rely on a single source. You don't want to have single source of failure. If one vendor is going down, maybe it's reliant on specific ISPs, maybe the way it works, it has some bottlenecks on specific areas. You just don't want to work with one vendor and have a single point of failure. And the third point is just geographical reach. So these broadcasts are becoming more and more international. People watched it from South Africa, Australia, India, all these places. And they expect amazing user experience. YouTube spoiled us as end users. Oh, no. OK. YouTube spoiled us as end users to have amazing user experience. Doesn't matter where you are, if you're on mobile, if you're in computer, and this is what we need as an industry to deliver. We found out that peer-to-peer is actually amazing to accomplish the exact same thing. So if you think about capacity, peer-to-peer has shown us that it just has infinite capacity. The largest event in the world, actually just last year when Windows 10 was updated, not too many people know, but it actually had peer-to-peer as its infrastructure, and it's extremely, extremely scalable. So by definition, peer-to-peer has infinite capacity. It's inherently distributed and fault tolerant, and it's ubiquitous. So if you have users in South Africa, this is where you're going to deliver the content the best, and this is where you're going to see really good user experience. So it's exactly the same. OK, so it's important to understand peer-to-peer has changed in the last 10 years. So it's not exactly the Napster or the BitTorrent you know, or Octoshape as well. So Octoshape is a CDN that Akamai bought and used peer-to-peer in the past. There's an important project started in 2012 called WebRTC. It is a peer-to-peer stack initiated by Google, together with Mozilla, Cisco, and other vendors in the industry to create a very stable, rich WebRTC stands for Web Real-Time Communication. So basically, you can build rich media applications in the browser without installing any software, any additional software, and it's very high quality. Luckily, it's now part of HTML5. It's standardized, and it's shipped in Chrome, Firefox, Opera, Microsoft Edge, and soon also Safari, which is the latest news. So we're really excited about it. There's a piece of WebRTC called the Data Channel API, which is a UDP and SCTP stack to stream whatever you want. You can stream any arbitrary binary data over there. And this is how we built our mesh network. So every connection in this mesh network is actually a UDP connection we manage. And any protocol can run on top of it. It can be HLS with H.264 or WebM or whatever you want. It's agnostic to the protocol. As opposed to previous peer-to-peer technologies, it's extremely secure. It's being updated constantly. And it's backed by very, very strong companies. That actually, Google bought a few companies, almost $500 million in 2012 and 2013, and outsourced, open sourced all this code. So it's really an amazing stack to rely on. And it has no end user installation, which is very crucial. Again, if you want to build like a YouTube kind of experience, you don't want anyone to install software. So it immediately works either on the web browser or in an app. OK, so there's another layer on top of that that needs to be built, which is what Peer5 built. It's the manageable peer-to-peer. So you want the peer-to-peer to be customized. You want it to be controllable. You want to have policies as a content provider. You want to decide exactly what happens. So for instance, what users should be enabled with peer-to-peer, what users should not. We recently introduced something called conservative peer-to-peer, which means that you as a broadcaster can say, I only want to enable peer-to-peer inside of an ISP or inside of a local area network. So for instance, if it's college sports, you can say, OK, peer-to-peer is a no-brainer, and I'm going to enable it for the inside the college local area network. This is where people are going to help each other the most. Well, while the rest are going to still rely on unicast traditional CDN broadcasting. Another key point is that it works well with other technologies. So for instance, HLS or Dash, the same data, the same payload is being delivered in peer-to-peer, and we're able to complement that technology very well. So this is what people call peer-assisted delivery, and I want to dig in a little bit more on that. So peer-assisted delivery means that as an end user, I'm receiving bytes both from the server and from the mesh network from peers. And there's logic that needs to happen to decide, OK, this next segment is going to be fetched from the server. This segment is fetched from the peers. And there are very different factors that dictates how it's going to happen. We advocate this hybrid solution. We don't tell customers, look, use only peer-to-peer. It needs to be, we believe that those two technologies complement very well each other. So it's a hybrid solution. And this is an example for video for HLS. So today, if you think about it, if you play HLS today, you simply buffer more and more content from the server. You build this buffer and you play it on the fly. And then people come and ask us, so how much delay does Peer5 add? How much delay peer-to-peer is adding? And the answer is 0. So we don't add any delay. We're just not interfering where peer-to-peer is not efficient. We just don't want to interfere. We want, this is the benefit of the hybrid approach. We just let the server work, which any CDN that you have is going to deliver maybe in the beginning of the session. But once enough bytes are buffered, we're able to offload to the mesh network. So typically in the beginning of the session, it's a server, but then you're connected to very efficient peers that can help you even more than the server. And as you can see, the orange boxes are segments from the peer-to-peer network. So once the buffer is, again, under some risk, the content provider can decide, OK, I'm still going to try to use the peer-to-peer, or a policy which says that it will fall back to the CDN. And it applies also to multi-CDN environment. So at the beginning of the session, something like Sedexis or your own custom CDN switcher can decide which CDN makes more sense for that end user. So I just saw outside that Sedexis has this, so chunk 1 is Akamai, chunk 2 is level 3. So I added to the slides the last example. I think typically most broadcasters still use this kind of like sticky session where an end user would go and it will use a single CDN, and that's fine. But even if an end user can switch between CDNs in stream, you can still have peer-to-peer during that session. So this is why it's so colorful there. And this is the overall architecture. So as an end user or as a video player on the client side, typically I would ask the CDN load balancer for the next segment and the next segment. So either it will decide on the beginning to work with a single CDN, or it will switch all the time. We inserted another layer called the hybrid switcher, which is client-based. So it can be JavaScript or in the app. And what it does, it just checks whether it makes more sense to go again to the server, to the CDN load balancer, or maybe there's a very good connection, there's a very high likelihood to receive the next segment faster from the mesh network. A mesh network is just a collection of peers that are watching the same content. It can sometimes called swarm. Typically, every end user has about 15 different peers that will try to help him as much as possible. And this peer group is dynamic. So over the course of 2 hours of live stream, an end user can have hundreds of connections that go off and on, depending on the user experience. So this is a bit cheesy, but peer-to-peer and HTTP works together pretty well. Complements each other very, very well. So HTTP is good for some things, peer-to-peer is good for other things, and the combination is very powerful. Especially for the use case of live streaming. This is where peer-to-peer inherently is very efficient. And a good example is the case of large live streaming. And I like to use this example. So Bob Bowen is an exec in MLBM, and he said earlier this year, or maybe even last year, that live streaming is going to be still on TV because basically when we use unicast, the streaming model tops at about 2 million concurrent viewers. So this is where you see CDN break, and I think he exaggerated actually. I mean, it's not 2 million. We saw Yahoo and Twitch and other broadcasters get to almost 10 million. That's my bet. Simultaneous at the same time. And it's not a bad number, but I think we all agree it needs to be higher if we want to really shift viewership from television. So this is a very nice example. The last India versus Pakistan game, and the finals, it was around 1 billion people on TV, which is 500 times more than what Bob thinks they can do. So definitely a long way to go, and in our opinion, there needs to be a transformational change in the way we deliver, because the gap is just huge. So it needs to go from around 10 terabit per second to around 1 petabit per second. It's just orders of magnitude different if we really want to serve these large audiences. So we believe that the way to do that can be using this multi-CDN peer-assisted solution. So where it says 4% versus 96%. This is our record so far. We managed to offload 96% of the bytes, basically. So it's called pure efficiency, which is very similar to cache hit ratio. It basically represents the amount of bandwidth that is offloaded from the CDN in this case. And let's see how it looks. It's pretty interesting to see it on this table. So what does it mean to have 96 or 99% pure efficiency to the audience size? So in this example, let's say the broadcaster has 1,000 servers. They use 3 different CDNs, and in total they have 1,000 servers. And each server can do 10,000 users per server. So this is kind of like a decent amount of users. So the audience size in this case, the best case, is 10 million concurrent viewers, which is a nice number, but definitely not sufficient. So if we're talking about offloading at a ratio of 96%, it means that only 4% is still on the server. It means that every server can now serve 250,000 users simultaneously. And it adds up to 200 million concurrent viewers. We're now on the verge to getting to 99%. And hopefully we will say that we can serve 1 billion people soon. So we talked about end users. So for them, it's better quality of experience. Content providers are increasing the capacity, the resilience, and reducing costs. What about the carriers and the ISP? It's also extremely important that they will benefit. So we've been working with carriers and ISP to give them more visibility, more control to the network, because it's very different than unicasting. And the idea is that they can have more internal traffic. They don't need to rely as much as they do today on peering. And eventually it will get to more throughput per ISP. This is also part of the journey to get to these audiences on the internet. What about CDNs? So CDNs can relieve those peaks that are. These are the times that are, I'm sure, the most stressful and unpleasant in the CDNs as well. So we can take those spikes, and they can help during the less spiky hours of the day. And this is actually how it looks. So this is a case study we did last month. It's 60,000 concurrent viewers on our system with 94% at peak. And so I hope you can see, but the green bars are representing HTTP, and the blue bars are representing peer-to-peer. And as traffic ramps up, we're able to take more. So when there's not too much traffic, and we're talking about maybe less than 50% peer-to-peer, but during the peak, in this example, it's a soccer game. So during that peak, we're able to take 94%. And just recently, we did an event of 300,000 at peak, which was also 96% pure efficiency at the peak. And you can see, so the CDN is still important and helpful in this case. In terms of quality of experience, so we measure it all the time. It's extremely important. Peer-to-peer is not about cost savings. It's a byproduct, but the most important thing is to actually improve the quality of experience. Nobody wants it unless, when we talk with broadcasters, maybe it's appealing that we save some money sometimes, but it's always crucial to really show that the quality of experience is better. And so this is a bit extreme. So here we see 75% reduction in buffering occurrences. So you can see, so the top is with Pure 5, and the bottom is without. And on the right, it's the loading time. so it's pretty obvious that it's two. So it's soccer, so there's halftime. So in the middle, it's just where people were out of the game, were not watching, and then they entered again in the second half, and that's where, without Peer 5, again they had high loading time and also buffering. It's fairly easy to test peer-to-peer because it's still using the same HLS or Dash protocols. You don't have to change your CDN. You can. The idea is that you have it on top. We see integrations sometimes within a day, and we actually have partners that help us. So you don't have to trust our numbers. You can use nice people at work or Conviva or Sedexis to measure and to try Peer 5 out. And easily switch it off and on. We also have our dashboard, which gives you quality of experience and the metrics about the delivery itself. Okay, I think we have, I'll finish with that. There's about 5 minutes for Q&A. Yes? Yeah, so the CDN is still doing HTTP ABR. It can be multi-CDN or not. And then as an end user, you're going to get some content from maybe the first segment from the HTTP server, the edge, and the next segment from using WebRTC from other users. Yes?
Could you elaborate on the client-side installation? Do you need client web technology or not?
Sorry, can you repeat?
Client-side integration.
Client-side?
Integration.
Yeah. Yeah, so it's not covered. I'll go over. Yeah, so client-side integration, good question. So the hybrid switcher is actually more than just one small box. What we offer broadcasters is to use basically a player plugin. So we work with JW Player, Video.js, all the player vendors, and we offer plugins that basically intercepts requests from the player to the server. So instead of requesting every segment from the server, it first asks the hybrid switcher, should I use the server or should I try to get it from the peers? So this integration is just one line of JavaScript or an SDK if you're building an app. Yes?
How do you handle like synchronization of different bit rates between players? So if they're usually AVR objects are independent.
So we try to keep as much as possible as it is today. So if you're coming with your own ABR, like you're using something like Dash.js or an HLS stack, so we're not changing that mechanism. So we're simply the delivery layer with the caching layer.
Do you have any insight into the efficiency lost due to different clients at different bit rates?
There's none.
No, I mean, but like if one guy's at the highest bit rate, one guy's at the middle bit rate, you're not going to get any efficiency.
Right. So definitely more bit rates are harder for us. So the rule of thumb is that at 10 concurrent viewers, we can get to 50% pure efficiency. But if you have 10 different bit rates, obviously we can do nothing. So it still applies here. You need about 10 concurrent viewers per bit rate to get to 50% efficiency. So I think like now people are getting less crazy about the number of bit rates they use. Used to use 10, but now 4 is more common. Yes.
Is there a way to integrate the client into Smart TV or set-top box?
Yeah, so there's either it's an HTML5 app, and in that case it's easier, or a mobile SDK. Yes, please.
How about the use of the upstream? Basically, peer-to-peer traditionally uses the upstream.
Of course.
Asymmetrical networks. Is that a problem? Either someone paying for upstream that they don't know about, or just the general issue with peer-to-peer?
Right. So first of all, they can know about it. It's not that we're hiding it. So we decided to let the content provider decide how to communicate it with the end users. It can also be an opt-in mechanism where you don't have to participate, but it can help you. So we hope people, would join. And it's very important for us to keep some bandwidth for other applications. For if you're trying to do other things at the same time, you can still do it. Yes.
How does the business model work?
Similar to other. So he asked what is the business model? So it's very similar to other CDNs. Basically, we only it's pay as you go. We charge only for the bytes that we deliver. Yes, please.
What's the security model so that you know that you're delivering segments are authentic?
Right. So great question. How do we know that the segmented are authentic? So first of all, it is encrypted, but you're right. It's not enough. So we verify the segments using a signature coming from the server. So for every segment that you finish downloading, before you play it, we verify that it's authentic. Yes, HMAX. Okay, thanks.